And yet, modern cosmology has suggested that maybe that's not the case, that we understand how our universe was sort of created and has evolved, and through that understanding we've come to think that maybe that's a process that could happen many times, that we could create not just this universe, but other ones.
Anthony, like most cosmologists, believes that 13.7 billion years ago, our universe rapidly expanded into existence, creating the heavens we see today. And he also believes that the forces of creation continue to generate a near infinite number of other universes, thanks to a cosmic mechanism called inflation.
So inflation is the process where a very small region of the universe with a very, very high energy takes on the properties in which gravity actually becomes repulsive. And this anti-gravity force pushes the universe apart. Sort of like the small piece of glass on the end of this gets blown up by a large factor into this sort of large and smooth expanse. So the universe, starting out rather messy and small, turns into something dramatically bigger and much smoother.
If this is the case, the immense cosmos we see today started off as a puny speck. In fact, Anthony's calculations suggest that the raw materials needed to trigger the creation of an entire universe could be held in your hands.
It turns out that the region that you need to get inflation going has a mass of only about 10 kilograms. And from that 10 kilograms, you get something that's this big, and then that expands into the entire observable universe. So immediately, you sort of start to wonder, if it just takes 10 kilograms, it's small, can't we just do that?
Anthony calculates that any 10-kilogram mass would inflate into a new universe, provided it is correctly compressed and heated up to 100 trillion degrees. Today, the hottest temperature we can reach is inside the Large Hadron Collider in Geneva, Switzerland. Here, tiny particles accelerate to near the speed of light and smash into one another, raising the temperature to more than 100,000 times hotter than the center of the sun. But it's not nearly hot enough to create a new universe.
A collider would have to be sort of solar system size. And we can imagine that far in the future, those colliders and accelerators and experiments will have attained the sort of energies that we need to get inflation going.
Over the next few billion years, Anthony's spacefaring descendants will have enough time to work out the details of building a collider the size of the solar system. If they pull it off, they could trigger an inflation reaction and create a parallel universe. But there's just one snag.
Unfortunately, if we could make this baby universe, it still would be frustratingly difficult for us to actually make the transition into that other universe. The bridge connecting our universe and the new baby universe would be both infinitesimally small and incredibly short-lived, a tiny fraction of a second before it would pinch off. If we tried to get to the other side, we'd almost certainly just end up in a black hole. Of course, this black hole would be so small that we could never fit inside it either. We should probably just leave it there.
If the only way to get to a new universe is through a tiny black hole, how would we ever move there? This scientist is working out how to pull off the greatest escape of all time. If he succeeds, we could survive forever.